Welcome to the Zero to Maker series, Introduction to Laser Cutting. This video is intended to be a supplement to the in-person class that is run as part of our Zero to Maker series here at the Tech Valley Center of Gravity, and specifically talks about how to use the BigRed laser cutter that we have at the Makerspace. So this video will cover fabrication methods, how laser engravers work, the materials that are involved that you can use with our laser cutter, and what are the safety considerations for using the laser cutter. Then we'll switch modes over to talking about what kinds of software and file formats you can use to produce files to work with the laser cutter, and where you can find pre-made designs on the internet that can be used for making your own cool stuff. I'll also talk briefly about design considerations and things that you should be thinking about if you're making your own design. And finally, we'll talk about the process for laser cutting and laser engraving using BigRed. So when we talk about fabrication, there are a variety of different ways in the world that you can make things. You can use a variety of different processes, but they generally fall into these three categories. Adding material, which is the process that is used by 3D printers. Removing material, which is the more traditional fabrication technique that you might use with milling machines, lathes, and laser cutters. And then shaping material, where you're bending, molding, or otherwise changing the shape of the material, but you're not really adding or subtracting the amount of material that's involved. For laser cutters, of course, we're dealing with a subtractive process, which is what the laser cutter uses. Laser cutters work by focusing an infrared CO2 laser beam onto a workpiece, and the material absorbs that infrared radiation and converts it to a localized spot of heat. That heat will melt or burn or ablate depending on the material properties that you're working with. The fundamentals are that there's a laser tube that is in the back of the laser cutter that is directing a beam from it that is somewhere around 60 watts in intensity. So if you think about a 60-watt light bulb, right, a lot of that energy output is coming out as light, but there's some heat there as well. And with the laser tube, it's all heat. So you have 60 watts that's coming out. It's being directed by these two mirrors, labeled 1 and 2 in this diagram, and is then focused down on the workpiece using a mirror labeled as number 3 that's on that gantry. And the idea is that using the two slides that are shown in this diagram, the entire work area can be addressed just by moving around on those two slides. So the beam comes back into the laser head itself, and it passes through a lens where it is focused down onto your workpiece. Now, in this head, there is also a gas inlet that allows fresh air to be pumped through and made collinear with the laser beam. And there's actually a gas jet that comes out of the nozzle at the bottom of the laser head. And this serves a couple of purposes. First, it keeps the particles and smoke and everything that's coming off of your workpiece from sputtering back up onto the lens, which would be bad because that material absorbs infrared, and if it's on the lens rather than on the workpiece, then the lens gets hot and you don't get as much work out of the workpiece when it's being cut. And that's problematic because as the lens heats up, it expands, and there isn't a lot of room for it to expand in its holder, and it cracks, and then it doesn't work properly. So the idea of the gas jet is, first of all, to keep material from getting back onto the lens and keeping that clear. The second point of the gas jet is to clear away any of the smoke or material that is being generated by the workpiece being vaporized by this infrared beam. And this is actually really useful because it can help catalyze the reaction that is going on inside the workpiece. In fact, industrial laser cutters that cut metal will be shooting oxygen in many cases so that they can enhance the reaction that is going on that's being created by the laser beam. All right, so now let's talk about materials. There are a variety of different materials that you can use with our laser cutter, and we have a wiki page that gives a list of the materials that have been tested and are thought to be safe to use in the laser cutter. However, if it's not on the list of materials that have been tested or that have been approved, you want to be careful because the chemical composition of the material and the way the material reacts to the infrared beam can lead to fumes that are harmful or other side effects. So you want to be very careful about what materials you're working with and make sure to stick with ones that have been tested. In case you have materials like PVC is a great example. PVC releases fumes that can be bad for you and bad for the environment. We'll get to that in just a moment. So when you're selecting materials, chemical composition is a big thing to consider. Will it release harmful fumes? And will it melt versus whether it will burn? So polystyrene is a great example of this. Polystyrene melts great, but it actually doesn't cut very well because what happens is the polystyrene curls at the edges. And so maybe that's a desired effect, maybe that's not a desired effect, but you need to be aware of the fact that it doesn't just neatly cut. Material properties can also change when they're being exposed to the infrared beam. And the other part that you need to be thinking about when you're working with the materials is how thick should this material be that I'm working with? Will it cut all the way through if I really desire to cut all the way through the material? And that can be really important as well. In general, we can cut thicknesses that are about 1/4 inch for acrylic or for light kinds of wood, but it really does depend on the material, and even from type of wood to humidity conditions with that wood, you can have a marked change in the ability to cut. So that's all worthwhile in thinking about when you're working with your materials. The other thing that you need to pay attention to is if you have a material that has a texture to it, you can actually see a substantial difference to how the material reacts to the laser beam just based on the structure of that texture. And this is a great example right here. You have a piece of wood that has a strong grain associated with it, and you end up with a tiger stripe pattern that shows up in your engraved area because the edge-on portion of the grain actually absorbs the infrared and chars more than the normal side of the grain. So this may or may not be a desired effect, but you need to be aware of the fact that if you have an inhomogeneous material that has some kind of texture, you might get some variation just because of that texture. So the laser cutter that we have here at the Tech Valley Center of Gravity is called BigRed, and it is located inside the electronics area right now. It is a 60-watt laser and has a cutting area of 600 by 400 millimeters. The nice thing about this laser cutter is it has some really cool features that make it a little easier to work with a variety of work pieces, including a Z-bed height adjustment that is controlled by 2 buttons on the right side of the instrument. The nice thing about that Z-bed adjustment is you can actually put rather tall work pieces inside the laser cutter to be engraved. So that can be really handy depending on the kind of project that you're working on. It has an integrated gas jet and exhaust system. Our previous laser cutter, which is still around somewhere but is not currently in service, you had to turn on the gas jet and you had to turn on the exhaust separately. When you turn the key on to turn on this laser cutter, it automatically engages those two systems. So you don't really need to worry about that. It makes it a lot easier and a lot friendlier to work with. The software that we're using with BigRed is called RDWorks, and it is a fairly nice package. It provides a number of features that allow you to take more control over how the laser engraver is working with your workpiece, and I'll explain that a little bit more in this video and also in the in-person class. So now let's talk a little bit about safety. When you hear the word lasers, oftentimes people will tell you, don't shine them in your one remaining eye, right? A lot of visible lasers, especially laser pointers and those kinds of things, you want to keep away from your eyes. You want to make sure that they're eye safe. The laser radiation that is coming out of the laser cutter itself is actually technically eye safe. And the reason why I say that is because the standard for eye safe is whether or not it does damage to the retina of the eye. Well, the eye is made of a lot of water, and water perfectly absorbs infrared. So any laser radiation that's coming off of the laser cutter itself or from the laser tube is actually going to be absorbed by the surface of your eye. Now that's going to be painful and unpleasant, and it's going to do damage, but it's not going to damage your retina. So even though some people will tell you, oh, it's an infrared laser beam, therefore it's eye safe, don't worry about it, actually still pay attention, because you can still hurt yourself with this laser, especially with 60 watts. So always keep the cover closed when you are working with the system and the laser is active. The other thing you need to pay attention to is this laser head can actually move around on the gantry very quickly. The fastest speed that it can operate at is about 500 millimeters per second, and that's pretty swift. If you are not paying attention, you can get your fingers pinched or mangled, so it behooves you to keep your hands clear of the machine when it's operating. Always a good idea. If something's moving around, keep your hands away from it. You also need to pay attention to fire as a distinct possibility with the laser cutter. Remember, you're focusing a very intense heat beam into a very, very small space. And on top of that, you're blowing fresh air onto the same spot. So that's pretty much a recipe for creating fires. So one of the things you always need to make sure of is that you're always with the laser cutter when it is doing its cutting operations. Never leave it unattended. And if you start to see it catch, or you start to see flames where you're doing the cutting, you either need to back off the back off the power that is being used for the cutting operation, or you need to speed up your laser head, because you're depositing enough heat and enough oxygen in one spot to create a flame, and that's going to lead to trouble. So always be aware of that. The other part of the safety consideration with the laser cutter, in addition to eye safety and fire safety, is the fact that when you're working with many of these materials, you can be generating noxious gases and smokes. And they're released, they're for the most part captured by the exhaust system, but you might get a little bit of a smell coming out of the machine as well. So you need to be paying attention to that. Most plastics will generate some kind of fume that is at least unpleasant to smell, if not partially harmful to you. So you need to pay attention to that and make sure that you have good ventilation when you're doing cutting. For certain materials, however, it's even worse than that. Materials like Kevlar, you might think would be a great material to work with in the laser cutter, because Kevlar is kind of hard to work with just by itself because it's a tough material. That's why we like Kevlar, right? Well, unfortunately, Kevlar and laser cutters don't mix, because Kevlar releases cyanide when it's cut with a laser cutter. So that's generally a bad thing. And even if you have perfect exhaust that's carrying it, that gas is going to go somewhere, and it's probably not a good idea to generate that. The other part of it is that some part of it might be deposited in the material, or in the bed or inside the laser cutter itself, so it's just an environmental concern. You don't want to cut Kevlar with the laser cutter. PVC releases chlorine, which is unpleasant as a gas, chlorine gas, but it's doubly unpleasant because it mixes with the humidity in the atmosphere and creates hydrochloric acid. So hydrochloric acid is pretty nasty stuff. It's a very powerful acid, and it will corrode the interior of the laser cutter, and it will corrode the ventilation leading from the laser cutter to the outside world, and the fan that's being used to pump the air to the outside world. So really, seriously, don't cut PVC in the laser cutter, because it's going to be a bad time for everybody. Last reminder is, just in case for some reason the exhaust fan does not come on, and you'll know when it comes on because it's noisy, but if it doesn't come on for some reason, don't do any laser cutting until you figured out why the exhaust fan isn't running. The exhaust fan should be used for all materials every time, no exceptions. So now let's talk a little bit about software that you can use with the laser cutter. The two-dimensional files that you use in the laser cutter can be created with a variety of different vector drawing tools like Corel Draw or Adobe Illustrator. You can also work with DXF files that are generated by CAD packages like Autodesk Inventor or 123D Make or 123D Design. The most common file formats that you work with are ones like the DXF file format that's coming from AutoCAD, or CorelDRAW's CDR files, Adobe Illustrators.ai. And in certain circumstances, you can load PDF, scalable vector graphics, that's SVG, and others. However, I will say that your mileage may vary, and certain packages work better than others in generating files that are compatible with the laser cutter. So there have been times where people have had PDF files that have needed a conversion to a different file format in order to be loaded into the laser cutter. That's just the way it goes. There are a variety of pre-made designs that are available on websites like Instructables or Thingiverse for laser cutters. These are becoming more and more prevalent as more people have access to laser cutters. And Maker Media's websites also have a great selection of projects that people have shown either at maker fairs or have published in Make magazine. So all these are great sources of files that you can make yourself. When you're doing your own designs, however, there are a few things that you need to keep in mind, and the first one is kerf. The kerf is essentially the size of the path that is being cut out from your part, and there are some considerations that you need to worry about, because if you have a part that is like this nested pattern on the left, what you'll find is that those two parts, when they're brought back together, will have a rather loose fit associated with them because of the kerf. There will actually be a separation between the two parts. But if you change your design such that the two pieces that nest together are cut separately and sized appropriately, you can make that a snug fit again. But it's something that you definitely need to pay attention to. This is something that you need to worry about whether you're using a laser cutter or a CNC mill or a router. Any of those things where there is a finite tool width that's involved, you have to pay attention to those kinds of things. And in most cases, it's not a big correction, especially in the case of the laser cutter, but it's something that you need to compensate for if you're doing design work. The other thing that you need to pay attention to is how you actually generate your design in the drawing program. And a great example of this is just a simple pair of boxes that you might create separately and then bring together because you'd like to make a rectangle that has a dividing line down the middle. In the case on the left, when you bring those two boxes together, what you will tell the computer is that it should be traversing that middle line twice. So the cut that you get, or the engrave that you get on that middle line, will be twice as deep as all of the other lines in that drawing. That might be a desired effect, but most of the time you're thinking no. So one of the ways you can compensate for that is to build a standard square and then just a three-sided figure and then put them together such that all paths are only traversed once. So something to pay attention to. When you're working with wood or anything that generates smoke, sometimes you'll notice that, especially when you're doing engraving, but also when you're doing cutting, that there will be some kind of smoke residue that gets deposited onto your workpiece. And one of the things you can do to clean that up is you can put a layer of masking tape over the area where you're going to be doing your engraving or your cutting. The beauty of this is that then the smoke gets deposited on the masking tape and not on your workpiece. You simply peel it away and you can get a nice clean figure. The other solution for this, if you're working with something that has a lot of detail and it would be a pain in the neck to pick all the little pieces of tape off afterwards, is you can cut it normally and then you can go and take a sanding sponge and just lightly scrub the top surface of your workpiece, and that will also remove the smoke. The disadvantage there is that you might end up with a little bit of sawdust in the very finest detail points of your workpiece, but if you're careful and you clean it out afterwards, I think you'll be okay. If you're working with a raster engraving of something that you want to have a very sharp definition to, sometimes it's a good idea to add a vector engrave after you've done your raster engraving. And the reason for this is because when it does the raster engraving, there's a ramp function that's used to go from the laser being off to the laser being on. And that can sometimes create a not very strong contrast at the very edge. So one thing you can do to make that pop is to outline the design that you've worked with. Again, you'd have to do this in your drawing program. And then follow your raster engraving up with a vector engrave. So that's one thing that you can do. Now, the other thing that you need to pay attention to is which technique should you use? Should you use a raster engrave or should you use a vector engrave / vector score? And one of the considerations for that is the question of how long it's going to take. On the left, you can see a raster engrave that is for 2 squares, fairly simple figure, and it took over a minute to do, whereas with a vector score or a vector engrave, where it's just following the lines of the square itself, it takes almost no time at all. So that's a consideration that you need to worry about. Now, the other thing you need to be thinking about when you're working with these pieces is the focus. The laser cutter has a gauge that you can use, and this will be demonstrated in class, to figure out how far away the bottom of the laser head should be from the top of your workpiece. And if you don't get this right, then you will find that the spot size that you're getting on your workpiece will be larger than what you're looking for, probably, with your design. So on the left, you can see an in-focus vector line, and you can see the defocused vector line by using a position that is further away from the laser head than what you would initially want. Now, there's a couple of things that you need to note about this. One is that for certain materials, this is actually a really bad idea because you can create a fire this way. When you are working with focused beams, you're creating a very, very hot spot in a very localized space. So the amount of fuel coupled with the amount of air is not at the right sort of fuel-air ratio to create a nice, vibrant fire, because you're only burning a very, very small portion of the workpiece that you're interested in. However, if you spread that heat out and you're still above the ignition temperature with your workpiece, suddenly you've vastly increased the amount of fuel that can be burned at any one time with this copious amount of air that's coming out of the gas jet. So if you're trying out defocusing as a fabrication technique because it's giving you an effect that you're interested in, tread carefully, and again, be aware that fire is a concern. So let's talk about BigRed itself. This is an outline for the process for doing laser cutting on BigRed. And essentially it involves placing your material that you're interested in on the cutting bed, opening up the software package and loading whatever artwork file that you've generated from another program. And then for each layer that you have in the file that you've loaded, adjusting the speed and power that are going to be used for that process. Now, when you're considering speed and power, and we'll talk about this more in the in-person class, that's basically determining how much energy is being deposited in any one spot during your process. So if you have a slowly moving laser head at maximum power, you are delivering the maximum amount of energy to any one spot along your path that you're cutting or engraving. If, on the other hand, you set the speed really high and you set the laser power low, then you're depositing the absolute minimum amount of energy that can be deposited on your workpiece at any one spot. And this is important because if you're working with a material that you think is going to be a flame risk, or you're not exactly sure how much power you need in order to get the effect that you want, the default thing that you should do is you should start with a high speed setting with low laser power and then slowly either dial back the speed or increase the laser power. Either of those two things are an effective strategy depending on what you're trying to look at. So back to this procedure line, for each layer you're going to adjust the power and the speed. And if you are concerned about fire, you'll probably want to test each of these settings independently just to see, is it going to give you the effect that you're looking at. After a while, you're going to develop an intuition with the materials that you're working with about what those settings should be for the kind of effect that you're looking for. But that comes from experience. It's not something that's really very easy to codify because a lot of materials can be different from batch to batch. So once you've got the layer speed and power set, the next thing is you want to turn on the laser and confirm that the laser switch is on. And again, in class, we'll show you where that laser switch is. But there's an illuminated switch that's along the right-hand side of BigRed. And if it's turned on, then that means the laser power is on. If it's dark, it's probably turned off. Then you want to confirm, now that you've turned the laser on, that the exhaust and the air are both on. You'll be able to tell that the exhaust is on because it's loud. You will hear it fire up. The air, on the other hand, you might need to put your finger underneath the laser head to just feel that jet of air coming out, just to confirm that it's there. You want to adjust the origin of the drawing that you're doing. In BigRed, the default is that the origin is in the upper right-hand corner of your drawing. And again, we'll cover this in class, but the important thing is that wherever you've placed your workpiece on the bed, you're going to use the arrow keys on the laser cutter itself to move the head over to the upper right-hand corner of where you'd like it to start drawing your artwork or your design. Then you're going to adjust the Z level. It's important to do this after you've figured out where the origin is, because if you just adjust it wherever it is randomly on your workpiece, and your workpiece is somewhat bowed or has an irregularity in its height, you could be adjusting it to the wrong spot. So it's good to sort of adjust it to where you think is going to be the average height of your workpiece. So you adjust the Z level using the two buttons again on the right-hand side of BigRed. And then once everything is all set, you check over your settings one more time, you click Start, and you watch the laser cutter do its work. Now, there's an emergency stop on the laser cutter. Again, on the right-hand side, it's a big red button. It says Emergency Stop on it. And if for some reason things are going horribly wrong, hit that button. It will cut the power to the air assist, the air jet, and also to the exhaust and to the laser and to the microcontroller and to everything that's associated with the laser cutting operation. The emergency stop is the go-to way if you have a fire of stopping the machine, because it does a number of things right away. First of all, it stops the laser from firing, which means you're no longer injecting that hot beam into your workpiece. And the second thing it does is it deprives fresh oxygen to the fire source. So between those two things, generally the fire will go out on its own because it won't have a supply of fresh air. If in the unlikely event that you have a situation where that isn't the case, there's a fire extinguisher that you can grab and put the fire out. But generally that's what ends up happening. So the process looks something like this. When you go to the computer that's attached to the laser cutter, get onto the desktop, you'll find that there's two places where you can open RDWorks on the desktop, either from the taskbar at the bottom or from the desktop icon along the left. And when you open the software package, you can load in the design that you're working with. Here's an example of a design that's a gear that's being cut out. On the right-hand side here, you can see that there is a tabbed area that says Work and then Output, Dock, User, Test, and Transform. We'll cover a lot of these settings in class, but most of the time you're going to be in that Work tab, and you'll see that there's a list of layers underneath that tab that shows, in this case, that there is one layer. It's a black layer, and it's set to a mode of cut. And you can see very quickly when you have this tabular format all the different operations that are going to be performed, whether it's cutting or raster engraving or any of those other types. For the most part, if you're cutting, it's going to be set to cut. And so for a cutting operation, you can double click on that line and it will open a dialog box which has a variety of different options available to you. In the file that's loaded in this slide, you can see that there's actually 3 different areas that have been delineated, 3 different processes that are going to be performed. The top one is a cutting operation, and its speed is set to 6, and which is 6 millimeters per second, and its power is set to 100, which is 100% power. In general, we don't recommend going above 90%. We're trying to save the laser tube, and running it at 100% will shorten its life a little bit. So keeping it at 90 is probably the better way to go. The cutting operation that's indicated by the red layer below that top layer is moving at a slightly slower speed of 5 millimeters per second and at a power level of 80%. And then the bottom line is an example of an engraving process rather than a cutting process. And you'll see that the mode is designated as scan, which is raster scanning. And you'll also see that the layer is denoted as being a BMP, or bitmap. In that case, the speed is 200 millimeters per second, because raster engraving is usually a very fast process. Typically, the speeds for that process are going to be somewhere between 200 millimeters per second and 500 millimeters per second. You can go slower, but it's going to take a long time, and probably you're going to end up with a result that's a lot darker than what you're looking for. And you can also see that the power is set to 90% as well. The last column there, the one that says output, that determines whether or not when you press start, that layer is actually put through the output process. So if you have output set to no in this dialog box, then that layer will not be drawn on your workpiece for this time. So in some cases, you might need to do some of these layers 2 or 3 times, others only once. This is a way for you to edit out which ones you want to run for a given setup. So that's an important thing to note. There are a couple of other settings that are here that aren't really terribly important for most users. So once you have all these parameters set, output, speed, and power, generally the min power and the max power are set to the same number. There are some advanced uses, especially with engraving and grayscale bitmaps, where you might want those numbers to be different, but that's an advanced topic, not part of our introduction process. So once everything is all set, you say OK on this dialog, and then you click Start in the laser work on the lower left-hand side, and that will get going. So if you have any questions, email srp-lasercutter@tvcog.net, and we will try to answer questions that you've got. Thanks.